Hello students. So in this video we are specifically going to talk about the spectral lines and what are the different spectral lines in hydrogen atom. So first and foremost we need to understand what is spectrum. So whenever an atom absorbs or emit energy, right, electron basically jump from one energy level to another energy levels. So when these jump happening, there are specific wavelength of light will be either absorbed or emitted. So this is what we call it as spectrum or spectrum lines. So there are two types of spectrum available. There is emission spectrum where atom emit light, and absorption spectrum where atoms absorbs the light. Okay, so a spectrum line is something which you cannot see in a naked eye. You just need some sort of spectroscope lens like a prism, diffraction grating, or something like that. So in this specific slide we are going to talk about the different spectral lines of hydrogen atom. So why hydrogen is so special? The reason why hydrogen is so special is hydrogen has only one electron. So the energy transition are very simple and it will give unique sharp lines, and there is a formula is also there to determine the wavelength of any series and so forth, depending upon from which shell to which energy level it is jumping and so forth. Okay, so there are five different type of spectral series are there. One is Lyman, Balmer, Passion, Bracket, and P-Fund. So Lyman series is where the electron falls to n1 is equal to 1. So basically it is falling to that energy level of 1. So here we can observe ultraviolet rays because the energy level is going to be very high. So if an electron falling either from 6 to 1 or 3 to 1 or infinity to 1, in all the cases the energy transition happening is going to be very large because it is jumping multiple orbitals. So it is giving you the UV radiation. The second one is Balmer series where electron falls to n1 is equal to 2. So this is the only visible light which is basically in the range of 400 to 700 nanometer. So only visible series of hydrogen basically. And we have Passion where the electron falls to n1 is equal to 3. So in this case we will basically experience a spectrum of infrared wavelength. Because the energy gap is very smaller in this one, so it is obviously giving you the lower energy. Then we have a Bracket series where electron falls to n1 is equal to 4. So this is also again infrared region, but the wavelength is a little bit higher than the Passion series. Then finally you have a P-Fund series where electron falls to n1 is equal to 5. So these are the five different series which is available as a part of hydrogen spectrum lines. So we have Lyman, Balmer, Passion, Bracket, P-Fund, all these things. So why energy falls as n1 increases, right? So the energy gap level decreases as n increases. So say for example, if you are if the electron falling from 6 to 5, then it is having a very small energy, which means the wavelength is going to be long. So few things that you need to understand is whenever the electron falling to the lower orbit energy level n1 is equal to 1, then that is the time you will basically get higher energy levels, which is basically UV light. And whenever it is n is equal to 2, you will get the visible rays, and after that pretty much you will get infrared or microwaves. Okay, so this is very important concept about the spectral series of hydrogen atom. Hope you all like this video. Please like, share, and subscribe this